In this fifth video, what we're going to do is we're going to look at integrating sine x or cos x of a linear term and what it gives us. So, first of all, let's have a look at two results which are given to us on our formula sheet. That if you integrate sine x, you get minus cos x plus c, and if you integrate cos x, you get sine x plus c. It's the opposite to differentiating, which is what you'd expect. Now, the way to think of this is it's sine x of a bracket. So if I was looking at this first example here, yeah? If I think of it as 6x inside the bracket, so it's a bit like what we were doing last time. So first of all, we integrate the outside function bit, which if we look at it is the sine, and we know if we integrate sine it goes to minus cos, so that would go to minus 2 cos 6x. Then we differentiate the inside of the bracket. It's a linear term, so it's just the number in front of x, the coefficient of x, which in this case is 6, and we divide by 6. And don't forget to add your constant at the end. Now, we can tidy it up a little bit. Minus 2 over 6 is minus a third. So I could write that as minus a third cos 6x, because we don't normally write in the bracket, though it is really in a bracket, plus c. That's how your answer will probably be written. Okay, let's have a look at the next one. Same idea, it's a linear term. So first of all, we know sine goes to minus cos. So if I'm having a look at that one, what I'm going to get is I'm going to get minus 4 cos 5x plus 2. Okay, that's differentiating the sine bit, but then remember, we divide by the coefficient of the x, which is the derivative, so it's minus 4/5. That plus the constant of integration c. And that would be that one finished. We don't actually need to do any more there. There's no tidying up to be done. Okay, let's have a look at our last example here. Now, if we integrate cos, it goes to sine. So this first one you could think of going to be 2 sine 2x. Then remember that's implied that there's a bracket there, so the coefficient of x is 2, so that's going to be over 2. That's the derivative of the inside of the bracket, which as I said is implied. Yeah, you could think of it like that if you like. It won't be written like that, but that's what it really means. And if we look at the next one, it was sine. Now remember, sine goes to minus cos, but minus of a minus is a plus. So that's going to be plus 5 sine 3x. And remember, again, you could think of that as really being a bracket. Okay, so if we differentiate that, it would give us 3. So that's all going to be over 3, plus some constant of integration, c. Tidy it up a little bit. Well, 2 divided by 2 is 1, so we can write that one just as sine 2x. You could write that as 5 over 3. You can either write it as a big fraction or 5 over 3 at the start. Sine 3x plus c. The only thing I would add, which is more important later on when we come to look at areas involving integration, is all these measurements, 3x, are in radians. When we're dealing with calculus, the trigonometric unit that we use is radians. So remember that for future. You should now be able to attempt the fifth exercise.